this.
All right, everybody. Welcome to another Chat Loop Back Off this week. Carlos is back. Take it away, Carlos. I'll be in chat to help answer questions. And today, what are we looking at?
Yes, today we're looking into one of these projects located here. So welcome, folks. This is the CNCF landscape. And at the bottom, you can actually see that we're going to have our big event in November 12 to the 15. Jorge, myself, and other cloud native enthusiasts, and going to be in Salt Lake City. So get your tickets before they go up in price. There's different tiers, so you haven't registered. So register for KubeCon, Cloud Native Con. So like every week, we have a different host. This week is myself. I usually do it in this way of like, we look into one of these projects that are in the landscape that people keep complaining and putting into slide decks and presentation, right, Jorge? And today I was given Kuma. So if you haven't seen this episode, the staff selects a project, and then the person hosting, like myself, we haven't done anything. It's a new project for us, so we're going to look at it with fresh eyes to see what is the getting started experience, and then tell you a little bit of what it is, how to get started, where you can get more information, and then maybe do a demo. So Kuma is a service mesh project. It's in Sandbox since 2020. So I always tell people, like, if you want to find information about a project, start with the CNCF landscape. It's the best place to go there. You can find the website, the GitHub repo, information about the stats, the contributions, and all those things. So let's move on to, we actually have a repo. So if you want to give us a star, I guess that's how you win the popularity contest in Cloud Native. Give us a star. So looking at here, it's a service mesh. Kuma was going to look at a file. They did apply for incubation. I was doing the research, and like I said, all research I have done was like literally last night and this morning. So I found that they opened a PR for incubation, but they closed it because they're going to apply again with the new process. But this file has all the information. Like I said, the link to this, all the links will be available, so don't worry about it to capture them now. And also, if you have questions or anything, drop them in the comments. I think we are on LinkedIn, we are on YouTube, we're on Twitter, we're everywhere. A questions, a comment, just say hi, maybe say where you are from. We are interested to always look and learn where people are actually doing cloud native around the world. So yeah, I started in 2022. Actually, 2020, like I said, incubation. 2023, it shows the recent updates that they did. It's a service mesh, like I said. One of the things that I'm going to look into is they support the new API gateway, which is I call it the Kubernetes Ingress V2. I know people are going to hate it. I call it V2, but it's Ingress plus plus. I don't know what to call it, but there's also Gamma, which is the service mesh CRs and the way that to use it. But we'll go into that. The company behind this project, I believe, is Kong. They have an enterprise offering with this. I think they're listed here. Kong. So Kong is one of the major contributor to Kuma. And there's also adopters using it and contributions on it. What else can we say? It's a multi-zone. One interesting thing I was looking into this morning was it's a multi-zone service mesh. So you can have the concept of zones. Probably maybe you have a Kubernetes cluster in one cloud provider in one region, like they say London and Europe, and another one in another place and different region. And those are zones that are connected through a control plane. So you can actually do service mesh from cluster to cluster. But everybody starts with service mesh in terms of like service to service, east to west traffic. So we'll look into that. Oh, they also support VMs. So you can, I think VMs or not Kubernetes called universal. It took me a while to understand the concept, but it goes like that. This is the repo. So let's go to the repo. And they have an org with multiple repos here. if you want to know, I think I closed it, but the landscape has information about stats. I usually use this episode. So if you want to know like what is the activity in GitHub for the project, you can go to the dev stats in CNCF. We have all the projects here in incubating, in Sandbox, and Kuma is in Sandbox right now. So you can actually see who's contributing, how's the statistics. So for example, we can see company PRs in table, and you can see who's are the contributors in the last, I don't know, 2 years. Um, you can see who are the doing the PRs, their GitHub IDs, their username. You can also see the commits. I think commits are here. Are interesting to see there's activity. So yeah, this is the one. So you can see like the activities and then which is the repo that has most activity, which is Kuma, followed by I think Kuma GUI, and Kuma has a GUI. We'll look into it. And then Go controller plane has a lot of commits, but that's a fork from Envoy. So Kuma is based on the Envoy proxy. Go control plane is a fork from upstream. So if you see a lot of commits there, it's just they're just syncing with upstream. So stats also you have to be careful on what are the information that you see, but that's just small bits of information, right? When you look at things uh, in this way. So let's get started. Let's get hands-on. I want to do some coding. Do we have any comments? I think comments are flying, and I still don't know.
You have so many questions.
Oh, we have questions. I haven't
Oh
started.
yeah. So many questions. Some of these are all right. So VG starts off. If I have an existing application, what are the steps involved in migrating to a Kuma service mesh? So maybe we might want to keep that in mind when you go through the thing.
Yeah.
Are there any specific considerations, best practices on that one? The second was Kuma supports both Kate and virtual machines. What are the advantages and challenges of each? And what are the practical implications of deploying Kuma's control plane in global or remote mode? That is the first set of questions.
Yeah, in global, I think in global, from the information I saw, and again, I'm not a Kuma expert, but I think I took some notes in here. Where did I put them? Videos. So in here, you will see a great video. I think I posted today in Twitter or X. That's not the link. Community calls is one that you can get a lot of information there. You can actually attend the community calls.
Yeah.
So yeah, I think I should give them the projects I do this a grade, right? I'll check what are the things that they're doing. Do they have a good project, a good website, repo, contributor guidelines, and such. There's a lot of things to go on for maintaining an open source project. So they have community calls. Watch some of them, very informative, and anyone can join on that. So yeah, let's get started, and I can ask some of those questions. And first one is
hopefully we can help answer some of these as we go through it, and then
we'll start with a hello world. I think the first one was getting an application. So let's go to the website. They should, the website is here, and the first thing that I usually do is install. Let's go my VS Code here. And I took some notes this morning to see what I need to do. I like to use kind. So let's create a kind cluster. I'm doing better this time. 9 minutes. Last time it was like it took for ages. So the other project that I want to shout out is I found this morning because some of these networking projects, Jorge, they assume that you have a load balancer and going to get an external IP. And then, you can use Minikube and Tunnel. I know all the tricks, right? So I wanted to know what's the easiest way to get with kind. And I found out that the guys from kind, the folks from kind and open source, they created this project called Cloud Provider Kind. So the maintainer is Antonio Ojea, which he's a superstar in the upstream Kubernetes project, and then a lot of other things. So it looks like he came up with this project that helps do the end-to-end testing and load balancer in upstream Kubernetes. And the idea is that we want to test, like when you create a service and you have a load balancer, that external IP gets resolved. So Ben and Antonio, gave a talk in the last KubeCon in EU Paris 2024, and it's super easy. So I already installed it. It's a binary, and it works with multiple kind clusters. You can actually have multiple kind clusters in your computer. You create a service load balancer, and voila, you have an external IP address that you can hit for your Mac or from your Linux for your laptop. The other alternative was like kind of Meta controller, Meta no Meta LB. So it creates you have to install the controller, and it works for the most part. But this one is a new one that you don't have to install anything in the kind cluster. So let's get it running. So I tweeted today about that. It's a binary, it's a Go binary that you just install and then run it. So I'm going to run it in this other terminal. I think I need to use sudo because, where did I put it? At least in Mac, the Docker engine is running. I don't know why they didn't do the fingerprint. But yeah, to be able to have the host IP address, you have to run the sudo. I think in Linux, you don't have to use sudo. And then the next thing that we have to do is, let me stop it because I think the first thing you have to do is kind clusters run with one worker node. So if you do get nodes, right, you get one control plane and you can have worker nodes. But if you have one, it has a label saying exclude from external load balancers. So just as a minor thing, let's remove that label and then run it again. And then this is like kind of like a Kubernetes controller running in your from a binary in your computer, talking to finding the kind clusters and connect it to it, and then reconcile. So we need that in a little bit when we create a service load balancer. I'll be showing the Kube API, Kubernetes API gateway implementation of Kuma. So for this, there's a little bug. I talked to the folks in Slack this morning. So you have to install the CRDs before you install Kuma, because the Kuma controller would check if the CRDs are present, and then it will create a gateway. If not, it doesn't start reconciling. So minor things that you find out when you are getting started with a project, right? But I gave feedback, and the folks were very receptive. They were able to answer questions on Slack. They already opened issues for the website. They opened an issue for this thing. So so far I'm impressed from the different projects I've done. So we just have a kind cluster. We have a couple of CRDs, get CRDs. If you do get CRD, you will see we have the gateway. So this is related to, let me show it here because maybe people don't know what I'm talking about. Kubernetes API gateway Gamma. It's called the project. Cannot remember. I think it's Gamma is the gateway API for service mesh. Oh my God, we in tech make naming things so difficult. But yeah, there's gateway API and there's gateway API for service mesh. So it has the CRD. So we already did install the CRDs. There's no controller yet. Kuma will be the controller to implement these CRDs. That's the benefit of having a standard way of CRDs, that then you have different controllers implementing it. The same thing with just the normal gateway API. There's reference implementations for them, a couple of them already. So let's move to Kuma. And to install Kuma, you can do it from the Kuma CTL, which you can install from the website. So if you go to, let me start closing things. I have too many things open. Where's the Kuma website? You can go to install. This is the feedback. Oh, now actually they fixed it by the time I did this live stream. So kudos to them. So you click the install button and you're taking it. You're taking here Kuma CTL, and then install a CLI. It's very handy to have a CLI for these projects because it short circuits some of the, maybe you have to do kubectl or kubectl with some Linux commands. So I install it like this. I think they're missing maybe the brew command. You can also install it with brew. So I already have it installed. The next thing is to install with Helm. So there's a quick start. If you do deploy Kuma, this is the example app that we'll be looking at, right? We're going to look at my app that listens of port 500 on HTTP that talks to Redis on port 6379 on TCP. I say that because that is important to know the protocols and to give the service mesh a hint of what is your protocol that you're using. Is using gRPC or using HTTP or using TCP. In this case, I'm using Redis TCP, which this morning I was looking for traces. There's no traces because it's TCP. We have to do it with HTTP. That's the only thing to be aware. They have a quick start, very quick start in terms of like using service mesh for connecting these two applications and adding the envoy. If you want to look at the introduction, it's very good in terms of the architecture. Let me see here what it is. So just nomenclatures. They call the data plane is this servers, this envoy proxies. They're based on envoy. So envoy proxies that sit next to the pod or the VM or the host, but the communication between services are going to happen from proxy to proxy. And then the reason for that is that's where the service mesh comes in. The policies that you see on the top, the monitoring for observability, and then configuring those proxies from the control plane. So you are interacting with the control plane, and somebody was asking about global versus local control plane. In terms of Kuma, you will have a control plane in that Kubernetes cluster locally. That could also connect to a global one as a zone, for example, to expose the zones that you have. But in simple terms, is you have a pod, you have another pod, since to keep it Kubernetes. You have your container, which is a service, and then a data is another sidecar proxy. Sidecar container, that is the proxy, is the envoy. And as you can see here, they show like all the type of things that can have like this sidecar extra container, the envoy that it sits in front of your service when you're going to receive traffic, and then when you're going to send traffic out, it will also intercept those calls, and those calls are done by changing the IP tables with a unique container. So let's go back. Let's install it. I was going to say there was another. So this part I really like. It talks about how it works. I think I already described it of like service to service. There will be proxies. Let me see if there's another one. Control plane to DP, or that's some of the nomenclatures. DP is called data plane. These proxies that you talk to. Also, backends are associated with the service, and then CP is associated with the control plane. So as I just described this, right? You have the Enver proxies talking to another Enver proxies. And most likely what people use service mesh for is to meet certain requirements in certain industries and regulations, where if you have a pod in one machine that is talking to another pod in another machine, that communication needs to be encrypted, and sometimes it needs to be mutual TLS. And one easy way to do it, instead of putting that burden on the services, on the apps, you put that concern on these proxies. And then the proxies are like encapsulating that communication with SSL and certificates to do the encryption and authentication. This is something that a lot of people, when start in Kubernetes or service mesh, I keep hearing service mesh, but sometimes they doesn't understand until actually they see a talk, or they see it for the few times, or actually play with it. But that's essentially what this service mesh is. I mean, there's other service mesh that use different type of. They don't use sidecars; they use something else, like a daemon set or tunnel. So there's different ways, and they compare that information. So let's get started. Let me go back to my VS Code. All the pods should be up. I mean, like Kite takes like a few seconds to come up. And then what I'm going to do is deploy this demo app. Well, no, I need to install Kuma. So let's install Kuma with Helm. And then this will install a couple of CRDs. Doesn't install much. Install a couple of CRDs and one pod, which I was very impressed. Usually I install things and I install like a bunch of pods. But I like the simple thing of like installing one pod, and that pod is a control plane. That pod doesn't receive like traffic. And the idea of these service meshes and having a control plane is you can kill, upgrade, kill the control plane pod, and your traffic still alive because the configuration is already saved on these proxies, and the service mesh is actually the proxies. The control plane is just to give it configuration, but it doesn't have to be up all the time unless you want to push a configuration. So that's it. This it's installed. How my fonts looks like, I don't know. People have feedback. Is that okay? The size, Jorge? See, I think Jorge told me that it was looking good. Okay, so I think it's looking good. So we installed Kuma. Kuma should be running in the Helm install got installed into a specific namespace. So if you do get pod/a, you will see that you have a new pod here, Kuma system, Kuma control plane, and it's one pod. And that's it. That's the only thing that I got installed. And then a couple of CRDs. So if you do get CRDs and grep for Kuma, you will see that you will see all the CRDs that this one controller reconciles. So that's basically the installation of it. You can also install it with Kuma CTL. Let me show you the command. So if you do Kuma CTL, I usually like the Helm because that is can be installed with GitOps, like in production real things. But this one has also an install command that you can install also the control plane or just the CRDs if you have like an imperative CI/CD stack and then observability stack, which is kind of like for development. It installs this stack for testing things. So let's deploy a demo. So let me keep CTL. I'm just following the tutorial here with the this thing, right? It's saying to install it with Helm. We did that. Install this demo YAML file and then port forward. But I wanted to look at this demo file. So the demo file, I clone the repo, and it starts with the namespace. And this is the first thing when working with the service mesh is you need to tell this controller to inject a sidecar container, the service proxy also any container. So anything deployed on this namespace now with this label, any pod deploy here will have that sidecar, that extra two containers, one init container and one sidecar. This one is the Redis. So like I said, it's just a Redis listening on port 6379, a service to expose the Redis on the protocol TCP. There's no app protocol because it's not HTTP. And then this is a demo app that talks to Redis. It listens on port 5000, and the service actually has app protocol HTTP. So this is important because then this will tell the control plane Kuma like, oh, this is an HTTP. I should handle HTTP. Or you can put a label, I believe, in the service and then put app protocol gRPC if you're working with gRPC. So that's another option. So let's deploy it. Where was that command? I think it was here. So we deploy this. This would create a new namespace and deploy the app. So if I do get namespaces, I see that there's a new namespace called Kuma demo. I'm going to use kubens to jump into Kuma demos. That's why it's a little bit easier for the commands for me to do. So if I do k get pods, let me make it a little bit bigger so people can see. I have my app and the Redis, but it has two pods, right? It has the init container that switches the routing for the port, and then it has that extra envoy proxy now, and the other one communicating with the control plane to get its configuration, filters, or any networking weights, secret breaker. All these policies are pushed to these envoy proxies now. And if we want to access it, I think we can also do like a port forward. So let's do a port forward here. I can run it. I can run it in a new terminal. Let me run it in a new terminal. Here, port forward demo app 5000, and I should open my browser, go to localhost 500. And that's the app. So if I increment, this is basically sending a slash increment. Well, no, it's incrementing in Redis calls local, a song called local, and it's 10. And if I refresh the browser or kill it or open it again, or that Redis is persistent, well, in memory, right? So that's the database, that's the app, the browser, the app, and this. We can also use one tool that I like to use is Netshoot. I was going to use Netshoot to do a curl from Edge to have traffic from something to HTTP so we can see some of the observability. So for this, I should be able to create this this pod using Netshoot, which I use actually a lot to troubleshoot networking things, and I do also to do demos. So yeah, I can. This is a pod running there. I can actually open a new terminal and see that it's running. So you can see it. Get pods. So now I have the shell that also has the init container. So from the shell, I should be able to do curl http / and what's the service name. So if we do k get service, k get svc. Oh, I'm doing it in the wrong thing. I think it's called demo app. K get svc. I have one service called demo app, another one Redis in this namespace. So I should be able to go and do a curl http / demo app or demo app.cuba. I like to put the namespace, at least the minimum. And the reason is some systems, for example, project that I used to work, Knative, it uses that to do the routing. So if you don't have it, it has difficulty for it. But we can do a curl and it doesn't work. I think it's because of the mesh. So we'll go back to the mesh to do the policy. I think I have to do the policy. So yeah, this the demo explains that it's the enable. Let me look at the chat. What we have here. Okay, we have some comments. Oh, this is super cool. So this is one of the super cool things that it has. The control plane has a GUI, so it has a port 5681. It has a bunch of them, but I should be able to do a port forward. I should be able to do a port forward on 5681 on the Kuma control plane on that service, and now it should be able to open it. And I see here that I have a cool GUI. That was the first thing I wanted to show. So here's the home. I have one global control health, 3 services, 3 data planes. Remember the app, the Redis, and my shell. And then this one, the mesh is called default. So when you install it, there's a mesh created by default. So if we go to, actually, here's the YAML. So I didn't create it, but when you install Kuma, it creates one. So if I go to, I need another prompt. I'm running out of prompts. Gate matches, I think it is. Let me see. Matches.kuma.io. There's one there. That's the one that we're seeing in the GUI, right? So all the data planes are associated with the mesh with the name default if it's not specified, and then the zone. So I think I only have one zone data. I have the services here, so you can see here I have the 3 services. One thing about Kuma is the services in the mesh, the identifier of a service in the service mesh is by port, and the way that their name is using a tag, or name. So it's the name of the service underscore the name of the namespace, SVC, and then the port. If the port is not specified, I think it's 80, which that's fine. Yeah, it's 80. Um, so that's how you can find it. So that's the internal ones. If can have external, you can have service mesh and those one. But this one is the first one. The gateways, we haven't looked at it, but we'll look at an example in a few minutes. So yeah, every time now I go here, there's communication. I keep incrementing the number. I can reset it. I can increment. I can put auto increment. So it goes crazy. A lot of requests from, there's no errors. So it's working. So that traffic is allowed. So the next thing that the demo does is, what about if you want to introduce zero trust security? So for that, you use a policy called mesh traffic permission. And basically you can create one that says, I'm going to allow that communication between all of them. And then I'm going to do a deny. And also enable mutual TLS. So let's do that. Let's create a mesh traffic permission first. This copy, I think it has a kubectl. Some YAML files don't have the kubectl, so you have to create the YAML beforehand. So this one is ready to go. So I'm going to create a mesh traffic permission. So, and then the next thing I'm going to create is mutual TLS using the built-in CA, certificate authority, but you can use the other options. One of them could be Acme, another one could be a private one with Vault, another one could be, but if they have support with AWS private certificate management. But this one is just a hello world, uses the built-in. Well, you can use the built-in for production. It's inside the cluster, is the trust. It's basically you're trusting it or not. And it comes with a secret. When you install Kuma, it comes with get secrets -n Kuma system. So there's a secret here called Kuma TLS search. So it creates a CA by default. It's self-signed. So let's create the mesh. Actually, I'm not creating the mesh. I'm editing the mesh. That's why it's the warning. I'm editing something that wasn't created with kubectl. So don't be afraid. It's just a normal warning saying you're editing something that wasn't created with the same client. But what we did was we added mutual TLS. We enabled it. And then the backends is CA, and the type is built in. So the idea is we're going to encrypt and do mutual TLS, the traffic between the app and the Redis. And for that, we can say, well, now traffic permission, instead of allow, I'm going to deny. If something's going to target the mesh and it's coming from, it could be the same mesh, the default action is deny. So we should have errors when we try to connect after doing this. So let's deny. So now we have mutual TLS, and I'm going to deny. So at this point, the demo application should not function because we blocked the traffic. You can verify this by clicking the increment button again and see errors. So let's go to the demo. I cannot connect. Look at that. We just blocked traffic. So you cannot connect from the demo app to the Redis. Let's see what's the next step of this demo is, so now everything's denied. Sorry, from mesh to mesh, nothing in the mesh can talk to anything. We can allow traffic, but now we want to only allow traffic. We want to allow traffic from the demo app to the Redis by applying a mesh traffic permission. So this one is already a mesh traffic permission. It's called MTP. I think this one was called the default. No, wait, this is the mesh, just the built-in. I think this one was, okay, so this one was the mutual traffic permission or mesh traffic permission that we created. We say allow, it works. Mutual TLS, deny, it doesn't work. And now we're going to create a new mesh traffic permission saying, leave this. It's like configuring Kubernetes network policies, right? Where you create a deny all by default, and then you start opening only the things that you're going to allow to communicate. So it's the same concept here. So this mesh traffic, I can make it bigger, people can see it, is saying like if something, the target ref is like if something's going to talk to, instead of the mesh, you say to a mesh service with this name, which I already mentioned, that this is the identifier where how you identify a service in the service mesh. It's like the service, namespace, service, and then the port. If somebody's going to target this from where? From a mesh subnet with the tags. So it's anything that has this tag, which this service that we had, it has this tag, then the default action is allow. And if you want to know where this tag is, which they should add this in this tutorial, is when you created these three services, you three objects get created called data plane. So if you do get data plane.kuma or data plane.kuma, these are global resources. So I have, and this is the name. So let's take a look at the Redis one, the app. So if I do this -o YAML, or I can make it colorful, we can do edit. I have some colors. Let me see if we have colors. Not that everything's blue. These tags, see here? These are the tags. When we talk about tags, it says this is a data plane, networking, the IP address. So this is the data plane, kind of like this is like representing the Envoy proxy, the DP, the data plane. So if you want to talk to that Envoy, you will do it on this port. If you want to check the health, it says the inbound when traffic is coming in, is the ready is true because belief is checking the port if it's open 5000, and then these are the tags for it. So this Kuma IO service, you can see it here. So this is how we're selecting this one. So if there's traffic coming in from this data plane or the service to the other one, that's how. I think that's at least how I understood it this morning when I was reading the docs. So it could be correct also. So yeah, let's create this thing, and then we're going to allow it. So only now things that are tagged with this are allowed to talk to Redis. So we do this, we put it here, and now we try to check out the app, check the button, increment should work. Look at that. We just created mutual TLS and only allow certain traffic to go through. So we did kind of like policies to allow traffic permissions in there. I'm doing good. What do people think? I'm doing good? You can comment. Let me see if that answers some of those questions. So I think I answered the question about how easy to take an existing app to make it work here. It's similar as other service mesh. Should be that easy, is around adding a sidecar. Some environments don't allow you to add a sidecar. So service meshes have an option also to do it through a CNI from the bottom to configure the networking to adjust. Well, you need the sidecar, sorry, the init controller. Sometimes they don't allow those permissions. So if you want to see what is get added, let me take a look at the pod so people know what I'm talking about. So the pod look like this, a simple pod for my app, demo.yaml, right? I'll move to the next demo, which is API Gateway. So the app looked like a deployment, and it just had one container called demo app. It's going to talk to Redis. This is the version, and then the color, I couldn't change the color, so I think that might be a bug. But if you do, that's the deployment and the pod. But if you do k edit pod demo something, then you would notice, oh, look at that, these other annotations that get added, right? Um, and this is information that the proxy will pick up, or you can do selections on that. The other interesting thing is, skip this for now, is, and this is, if you're going by in YouTube and looking at a screen with a lot of YAML, you can guess, right, that we are talking about Kubernetes. There's a lot of YAML, um, for everyone. If you're hungry with YAML, you should work on Kubernetes. So we have an init container, and then this one has special capabilities because we'll be messing around with the networking for this pod. So it will be adjusting. Like now, when you talk to port 5000, normally you would talk directly to the container. But in this case, this init container will switch out, saying that traffic that goes for port 5000, instead of talking to the container directly, it's going to talk to Envoy, and then Envoy will manipulate for example, the HTTP request with adding a header or adding a delay or authenticating. So it will connect first to Envoy and then we'll go in. So this is an init container that runs. It modifies the IP table, or they call it X tables. And then these are the instructions of like install this in here, and then these are the instructions on it. And then the other container that boots up is not in the new versions of Kubernetes. There's an init container that you can leave it running. It's called the official sidecar support. In this case, they're not using it for a good reason, or because they might work with an old version of Kubernetes that doesn't support it. But they use the sidecar container, which is just another container, normal container, which is going to look it up. It's going to be this one. So this one is going to run Envoy, but it's an image from Kuma. So they put things on it, and the releases is Kuma DP, Kuma data plane, which is Envoy. This is one of these containers, and this all the configuration from it. The certificate, the CI certificate, because this Envoy will be talking through the Envoy protocol to the control plane, and then to connect through HTTPS or SSL, it will need to trust the control plane. So the certificate CA is inserted here. And then at the bottom is your normal container. So yeah, again, this can be also be done through the CNI, the part of the init container, but you always need the Envoy proxy there. Let me close this. I think, oh, what happened to my terminal? Did I lost it? Bring it back. Hopefully everything is up. Just hitting. We have a question. How can CNCF projects like Kuma integrate and enhance the use of distro-less containers for better security in service mesh environments? Projects like Kuma. So distro-less containers, or containers that only have the minimum amount of files, operating system files, usually like the CA information, or like the famous open source project called ChainGuard. It has 0 CVEs. Their containers are the minimum amount of OS files, also free CVEs. One thing that the integration could be the Kuma project, or it's like any CNCF project. More CNCF projects could coordinate with this open source project, for example, ChainGuard and other projects like that, to have their software be delivered in that way. I don't know if Kuma is already like distro-less or has the less minimum file, but or maybe it's using something like Ubuntu and all the files from Ubuntu that are not required to run Kuma. But lately, a lot of the Kubernetes ecosystem or cloud native ecosystem, they use Go, and typically they just use the minimum amount of container and then compile and go. But I don't know. You can check their repo to see if they're using distroless or not. But that will be one way CNCF projects can start integrating more, I will say integrating more distroless mindset, right? Do not include files that are not needed in the container image, and use a base image like something from ChainGuard or some other project that supports 0CVE or distroless. So yeah, if people don't know what I'm talking about, ChainGuard, they have images, Wolfie images, ChainGuard.dev is the project, and they're on GitHub. On GitHub, they have a pay offering, but they also have open source. So it's called the ChainGuard images. That should be on GitHub. I don't see the link to GitHub. Open source. Yeah, I don't know where. I cannot find it now, but yeah, that would be one way of doing it. So yeah, we have a few minutes, so let's do API Gateway. I want to do API Gateway because a lot of people are talking about it, and they want to learn about it. So let's look at Gamma. So I already installed the CRDs. I don't know where I got the command, but it's somewhere here. So I installed the CRDs and I installed Kuma, and Kuma has a little example here. Using Kuma, managing incoming traffic with gateways using Kubernetes API Gateway. So you need to know where to find this demo. So the first thing is to install, here it is, the gateway CRDs. So it's from the guides. That's where it is. It's from guides, user guides, getting started, and then you install the CRDs. And this will be for any implementation. That's the idea of having a standard. You install the CRDs, and some other project takes care of reconciling them according to the standard. So that makes it easy if you want to move from one implementation to another implementation. You don't have to change your APIs that you call through YAML files or REST APIs through the Kubernetes API. So let's do that. I think I have the command in this little README here. Let's go back to here. And so this command. So I need to run this command, install, and it didn't find kubectl. What? Oh, I'm running in this shell. Let me exit the shell. I'm not going to do the shell today. Let's copy it here. So I think I run out of time. So this install a few CRDs. This install, how many? Install a gateway class, a gateway that points to a gateway class. So a gateway will is in charge of creating an instance. We have gRPC and HTTP routes. They're a little bit different. And then I'm not sure what reference grants are, but I don't think we're going to touch them today. So after this, we install Kuma, which, I think I installed Kuma before installing the CRDs. So there's this little bug in Kuma that you have to install them in this order for Kuma to reconcile, to give you a gateway. So for example, we go back to here, it says, if you install with Helm or kubectl, gateway class named Kuma is automatically installed here. But even if you install it, it will not reconcile it. The gateway class. Let me see the gateway class. Yeah, it will not do the gateway class. And even if you create it, it will not create it. So let's do a trick live now. Let's restart the control plane to see if it will do it. So if I do kget gateway class, oh, there's there. So maybe I did install it, or maybe they fixed it, or maybe I drum it. I thought it didn't work this morning. But anyway, we have a gateway Kuma. So we don't have to do anything. Maybe I did. I'll watch the recording. So the next thing that we have to do, we have a gateway class. Gateway. Oh, we already have the gateway classes. With the control. So let me show you the YAML. Let's see the YAML. So it's a gateway class with the name of Kuma, and the spec is which controller what's the controller name that is going to reconcile this, and then you point to gateways Kuma.i controller. If you're using a different implementation of the Gamma, it will be a different project name, for example. So that's there. What we don't have is get gateway dot. So we don't have a gateway. So we have a gateway class. So let's create the gateway class, the gateway. And these ones don't have the YAML, the kubectl command. So you have to create the YAML file and then apply it. I already did this morning. So I have the gateway here. So let's create this one. So this is the gateway pointing to a gateway class that is already there. Kuma, and it's going to listen on port 8080 and on HTTP. So let's apply-f gateway.yaml. And then the next thing that we have to do is, see, this gateway will create a pod called Kuma something, and that's going to be the gateway listening on port 8080. Redis and demo app should be already there because I deploy them, right? So if I do get pods, now I have Kuma, and I have my app, I have my Redis. So then the next thing that I want to do is we can look at the services. So this is the reason why we had the cloud provider load balancer. So I created a load balancer, this gateway that is listening on port 8080. So I want to access it from my laptop. For that, I need an external IP. But if I use kind by itself, it doesn't do it. That's why I'm running this extra command cloud provider kind somewhere here in the background. Where is it? This one. So that means if I go and I do get service, now Kuma has a load balancer and I have an IP address. Amazing. So I should be able to do curl against this, and then whatever route I configure on the gateway, it will route to a service. So we haven't done that yet. So now we have to do the HTTP route. And I'll create the HTTP route, and then I will show what are the Kuma objects that these CRs from API Gateway from Gamma are creating behind the scenes. So at the end of the day, this is an interface. You create these YAML files with standard API Gateway Gamma, and then behind the scene, the controller will create the Kuma equivalence ones, and those are actually the active ones. So let's do this one. So this one is an HTTP route that is going to send traffic to our demo app on port 5000. Weight is 1. I don't think you have to specify. And then if it matches /, then send it to this. So this is a typical route. So let's create it. The route is here. Same thing. It's going to send it to my service called demo app on port 5000. Remember, this is the port that I'm exposing the service, not necessarily the one that is listening on the container. So people get confused sometimes. So let's apply it. Okay, apply-f HTTP route. And now we have a route. If I want to see the equivalence, it will be of the gateway class and HTTP route. So for example, for HTTP route will be get mesh HTTP get mesh HTTP route, and I do -a, and it's going to create the mesh HTTP route in the kube system where the control plane is kube system, and with this name. So it's echo Kuma demo something. This is the target reference to it. So it has the name echo. I think that I put echo somewhere there, but it's the demo. So that's the HTTP route, and then we can curl. So let me see if that's the thing. Yeah. So now we curl to that IP address on port 8080 with /, and we should get back the response from that pod. So let's do that. What's the IP address? Get service is 172.3. So if I do a curl from my laptop, right, on port 8080, which is the gateway slash, I should get back the access denied. Oh, because I think because I put the deny all. So it's working. Our deny all is working. So we need to switch it to allow all. Let me do that quickly. Kubernetes. So if we do the allow all back, what's that command? This one, allow everything back up. Come on. There you go. Now it works. See? So the gateway cannot talk to the app because I put a rule in my cluster saying if you're part of the mesh, you cannot to talk to anything, only demo app to Redis. So in this case, I block myself, right? This example should put out if you did the other one. But anyway, we got it running. We can even do version, and we get back the version and the color of this thing. Actually, I can run it from my laptop, right? From here, now we can access it on my laptop. Here's the app, the same app, but now it's going through API Gateway Gamma. I think that's it. Let's take some questions. People have questions. We have
I think
that's
it for the questions there. I think VJ, hopefully we at least got most of them there.
Yeah, and Kuma was talking about VMs. Kuma has it's called Universal, so you can download just the binary, or you can run it from Docker. Like the CP is the control plane, the data plane is like the proxy. It's VM.
It's just a single binary for all.
I'm not a fan of VMs, but
Yeah.
you have to construct it, right? If you have a VM that you want to wrap around the proxy, right? You have to, and you're not using Kubernetes at all, right? You have to run the control plane. But if you have the control plane in Kubernetes, right, you can put the data plane in the VM, and then that data plane can be controlled from the control plane that is running in Kubernetes.
I think someone's tried this with Firecracker. That was my first. That was my first thought that popped in the back of my head when I saw these.
Let's try what with
throwing these into like a Firecracker VM.
Yeah,
something light. I think one of the super light ones.
Yeah, I think the use case is more for legacy applications, like modernization, where you have you already have VMs, a bunch of them, and you want to make them part of your network mesh, right? So how do you add them? Is just put a little proxy in front. I'll say in front, but the proxy has two parts. It's like in front and on the back, because any ingress coming into that VM and any egress coming out of that VM, now you have control over who talks to it and then what things it talks to. So you can control it's a hamburger. So it becomes the bond. So the envoy is the new bond of the hamburger cloud native shop. So because sometimes people think it's only the ingress, right?
we gotta make that a thing.
But remember that you're encapsulating all the connections, right? You're changing the ports in IP tables. It feels like magic, but essentially that's what you're doing. Any traffic going into this process, any traffic going out of this process, now it's going to be inspected, mutated. Maybe you need to add a header, right, on top of it. So that's what service mesh is about, and this different implementation of service mesh. I don't know if it mentions here in the gateway Gamma where the implementations are for Gamma. I know for initiatives, implementations. So there's implementations list. So for the controller, for the gateway controller, there's a bunch, which is very popular. Oh, here it is. So we have three. We have Istio, popular, right? Kuma and Linkerd. All of three are very popular. It looks like Linkerd is experimental. But that's the idea. Like the same example that I did, literally the gateway class, HTTP route should work on Istio or Kuma. now that you're using cloud Kubernetes or cloud native standard APIs. When it comes into, I'll close in a minute. People ask me, or ask like, what's the bit of like using HTTP route with service mesh? Is because this HTTP route that I showed, where is it? Let me see. Discovery, route and traffic. If you notice, where is the thing that I was working on? There it is. No, using Kuma. My God, where is the API gateway example?
Use a search.
Here it is.
Oh, there you go.
So if you notice, typically for API gateway, is north to south. So your HTTP route that we were looking here was this parent reference. You point the gateway to the gateway that is usually sitting on the north, saying, I want to receive traffic from this gateway. And when traffic goes into this gateway, route it to my backend. When you're talking about service mesh, then you can change this pattern ref. Instead of like saying it's coming from a gateway, now it's coming from the east. It's coming from another service, from the service mesh. So what they did in the spec was they didn't create another mesh HTTP route or anything like that, like Kuma has, which Kuma is the implementation. They just say, well, instead of the traffic being from a gateway, it's from a service. So it's service to service through that. And it talks about here HTTP customization. I think it gets to service. So let me see for a second. Different zones, service route. So when it comes to service mesh and API gateway gamma, here's the trick. You put HTTP route, but instead of parent ref being, hey, I want traffic from the gateway, say, hey, when traffic comes from the demo app to the Redis app, this is what I want you to route traffic. And it could be like weights, or it could be whatever is supports the HTTP route, which is the new standard, the new Ingress v2. I know like other people will kill me for calling Ingress v2, but I call it Ingress v2. Is HTTP route. So I get, at least it was easy for me. I found a little box on the implementation, on the documentation, on the quick start, but I posted them this morning in Slack, and like day and a half, last night this morning, I was able to pick it up. What do you think, Jorge? I did a good job.
Yeah, I love to see it. I love to see it. I love to see it. All right, close us up, but toss the URL to your notes in the CLBO GitHub.
Yeah. Then, we'll merge the PR. PR is open for Kuma. Put some notes in there. If you have all the links that you want to add, put a comment in the PR. So I don't know if I can post to the messages thing. I think you are the one.
I got you. I'll go ahead and post that there. Boom.
And then also the link to, I think I already have it, but let me put it here. The cool thing that I learned today for Kind, getting a load balancer.
I already posted
Antonio.
that in there.
Okay, yeah. Great.
The I tweeted that independently. Kind. Yeah.
Okay. Yeah, they gave a talk. I missed it. So many talks in KubeCon. So we want to see more talks. Comes to Salt Lake City in November, and the CFP is open for London. So submit your talks if you want to speak at London. We'll be looking at that soon. So Jorge, I think this is an episode. What do you think?
This is an episode. Wrap it, put it in the books. Thanks everyone for listening in. Appreciate the engagement and the questions. And we'll see everyone next week. Remember, if it's Thursday, we're going to break something. So thank you.
Yeah.